This is Emily Haskell, and I'm going to present on the Next Generation Science Standards, or commonly known as NGSS, for my EDL 680 class from San Diego State University's Graduate School. I chose to present on Next Generation Science Standards because as a kid, I didn't have a strong love for math and science, but as an adult, I definitely do. I find its like value and how fun it is and exciting it is. And I think I just didn't love it as a kid just from a lack of confidence. And so I feel a strong dedication as an adult and as a teacher and administrator to really champion math and science. So there are several needs. There are several needs for the standards to change. And a couple of those are the reduction of the United States competitive economic edge. In a study from 2010, it said that half of US patents for technology were actually filed from foreign companies. The lagging achievement of United States students on national science tests, the essential preparation for all careers in the modern workforce, that employers are finding the need for their employees to be able to be stronger critical thinkers, and a better background in science and math, and that the need to have a scientific and technologically literate, educated society. NGSS is built on this idea of three-dimensional learning, but all the standards have practices, they have core ideas, and they have cross-cutting concepts. So that it was developed by the National Research Council. We have 8 science and engineering practices, 7 cross-cutting concepts, and 44 disciplinary core ideas. So in practices, we have science and engineering practices, our first section of our three-dimensional learning. And the engineering, in my opinion, is the biggest shift to these standards, that this addition of engineering. In the center picture, you have 5th graders who are engineering or designing roller coasters, and they have to think about lots and lots of different concepts of physics to kind of get them to work, and a lot of trial and error. The picture on the right was a challenge of having to build a tower a certain height. It had to be able to hold a certain weight, and you only could use index cards. I was a teacher and currently an assistant principal in a district in Fairfield, California at a Title I site. And this isn't from my class, but it's from a colleague's class last year. And the challenge was to build a bridge that would hold Cinderella's carriage, not her castle. And so it had to be so high off the ground, so many feet or inches long, and that all the kids were given the same materials. This first video shows this girl, Melanie, really struggled for a long time in school and continues to, and just being able to verbalize her learning, but she was a rock star when she did this. She could explain everything that was happening. What's really funny here is they're explaining that they really want to make their bridge beautiful, and so that's kind of where they started, which is an interesting kind of take on engineering. This next group, I'm asking them kind of what they realized that the bridge was collapsing in the center. So they're kind of building these supports to hold it up. As I walked through this room, it was 100% engagement. Each group was talking to each other. You had really robust conversations and some disagreements on what would work, and a lot of trial and error. This addition to science and education in general is very, very much needed. As students work together, especially in this idea, pulling in engineering, which is with these really fun challenges, it is only going to strengthen math and literacy and language development. It's only going to strengthen every other area of education, which is really exciting. The next section is these cross-cutting concepts, and the cross-cutting concepts are found where you take a standard, they have these different other areas in them, and they include patterns, cause and effect, scale, proportion, and quality, systems and system models, energy and matter, structure and function, and stability and change. And the last is the disciplinary core ideas, that all of the standards revolve either in physical science, life science, earth and space sciences, engineering, technology, and the application of sciences. Currently, as I said, my district is kind of tinkering with the NGSS. Similar to Common Core, there isn't a curriculum yet because there's not going to be one that's good enough. So they're kind of just playing with it currently.